Hi, Assalamualaikum to my respected lecturer, Prof Nur Izan. My name is Nurul Adini binti Abdul Latif and I'm a first semester student of MMFB from FTKIP UTeM. And as for today, I would like to make a presentation on the answer for assignment for the subject of advanced manufacturing process. Let's go through the question. Okay, here goes the first question. Figure 1 show a set of metal product machined by a non-conventional machining process. Suggest the most suitable process to fabricate the metal products. Justify your selection. Describe the working principle of process selected. And discuss 3 significant process parameters that can affect the process. And here is the second question that we are going to discuss further on this presentation. So it is given a table of parameter for the laser welding was conducted on 2 workpiece that is stainless steel and low carbon steel. So we need to calculate it. And after calculation, we need to justify if the stainless steel workpiece was to be welded with ND laser and eczema laser. Justify which joint will give higher depth of penetration, and then discuss 3 reasons why water jet machining can be an interesting non-traditional manufacturing process for ceramic industry. Now we go straight away to the answer by seeing this image. The non-conventional machining that is believed to be used to make this product is by laser cutting process. The reason of why I choose to state the laser cutting is because many metals can be cut precisely with the laser by varying power, feed rate, spot size, and gas type and flow. And laser cutting is actually very fast, flexible, and cost effective. So this is actually a brief introduction for the answer at number 1. So a non-conventional machining for produced product as per image in the previous expected to known as a sheet metal fabrication process. So there is 4 main classes of the process, which is cutting, forming, punching, and lastly welding and joining. So by seeing the image, it is actually believed it is from the class of cutting. So cutting process can be challenging. Depending on the material and the cutting method. For instance, stainless steel, it is difficult to cut with a saw blade but cut easily with laser or water jet cutting. The main cutting process include there are 4 classes, which is plasma cutting, laser cutting, shearing, and water jet cutting. So plasma cutting and laser cutting are 2 commonly used techniques in sheet metal fabrication. So plasma cutting use a plasma cutter to cut through metal, while laser cutting use a high power laser to cut through sheet metal. So it is believed that the previous picture that we saw is from the laser cutting and it uses a high power laser to cut through sheet metal. So we go straight to the working principle of laser cutting. The working principle of the laser cutting. Laser cutting is a non-contact thermal based machining process that utilizes the high intensity focus beam of a laser to cut through materials. So here is the working procedure for the laser cutting. So the working principle of laser cutting involves several steps. First, generation of the laser beam itself. laser cutting start with generations of high intensity laser beam um, by achieved using a laser resonator, which stimulates the emission of a photon in a coherent and collimate manner. And then after the laser resonate, the laser will be amplified through a gain medium, often a gas mixture or a solid state crystal. And then mirror and lenses are used to focus the directs of the laser beam into the highly concentrated small diameter spot. And then after the amplification, and then it goes straight to the material interaction lah. The focused laser beam will be directed onto the material to be cut, and then the beam interact with the material surface. It will generate intense heat due to the due to the absorption of the laser energy. And then after the heat absorbed, the next step will be matting and vaporization. So the material at the focal point of the laser beam undergoes localized matting and vaporization. The intense heat causes the material to transition from a solid to a liquid, and in some case directly to a gaseous state. So there goes the objective of the laser cutting lah, material removal. As the material is melted and vaporized, a jet of gas, often an acid gas like nitrogen or oxygen, is usually employed to blow away the molten or vaporized material, leaving a cut or curve in the material. So there it goes lah. And then let's watch how it works. So as we can see here, it's very fast and flexible. We can make any patterns that we desire, but yeah, it's very advanced technique. Okay. So then we go to the last question for the question 1. The 3 significant process parameters. That is finding laser power, and then laser power refer to the amounts of energy delivered by the laser beam per unit time. And then the second one is cutting speed. Cutting speed is actually a rate at which the laser beam move across the material surface. So how fast it can go along the material surface. So the third one is focus position and spot size. The focus position refers to the distance between the laser focusing lens and the material surface, while spot size is the diameter of the laser beam at the material interaction point. So, and then we go to the question 2. The question 2 is to determine which set of laser welding parameter will give a higher depth of penetration of stainless steel and low carbon steel. So the formula that we can use is here we need to calculate the heat input first, and then the heat input first, and then heat available for welding. So the expected result after calculate these two methods is actually the higher value of heat available for welding will provide greater depth of penetration of the welded material lah. So for the first material, stainless steel, the heat available for welding is much higher compared than for low carbon steel, which is it show 1029 joule per second, and for the low carbon steel it is 405 joule per second. So the we can conclude here by seeing this by seeing this value, the set of parameters for stainless steel give a higher heat available for welding, which is 1029 joule per second, compared to low carbon steel, which is 405 joule per second. Therefore, for the same size workpiece, the set of parameters for the stainless steel will result in a higher depth of penetration in this laser welding process. So to support this value is actually from the notes I found this also. We can see how does the effect of laser power to the material to be welded. By increasing the voltage value, it gives the higher value of power. So due to that, it will resulting in deeper penetration. So you can see here how the deep of the hole. And then we need to differentiate the NDX laser and azimuth laser are two different types of laser that operates at different wavelength and have distinct characteristic. To determine which one will give higher depth of penetration for stainless steel, we need to consider their respective absorption properties in the material. So the wavelength actually different lah. So by seeing the differentiate by the wavelength, we can see that stainless steel tends to absorb UV radiation more efficiently than infrared. So the shorter wavelength may result in higher absorption and potentially deeper penetration. So considering of the higher absorption of UV radiation by stainless steel, the azimuth laser is likely to provide a higher depth of penetration compared to the NDX laser for the welding stainless steel. So for the last, which is the water jet machining, is a non-traditional machining process that utilizes a high velocity stream of water to cut, shape, and machine material. In the ceramic industry, water jet machining can be an interesting manufacturing process, such as a non-thermal process, which is not generate any heat. So it is crucial for the ceramic because it is often sensitive to the thermal stress. So the second one is high precision and intricate shape, which is the water jet machining capable of produce high precision cut. So it is allowing for the ceramic to for complex design, meeting the demands of the ceramic industry where precision is often the critical factor. And for the last is no tool wear because water jet machining is a toolless process. So will not suffer from any tool wear lah. So in summary, water jet offer a non-thermal, precise and toolless approach that aligns. So there is three advantage to be offered by water jet machining to the ceramic industry. Okay. So I guess this all for me for this presentation. As for the summary, in this assignment, I got to know the non-conventional machining process such as laser cutting, laser welding, and water jet, and being able to identify by its principle and parameters. And parameters require good understanding and um, the advancement in laser cutting and laser welding technology continue to introduce new feature and control to enhance the precision and efficiency of the process. So, thank you for now. Wish you all have a good day. So, goodbye. Assalamualaikum.